So we are going to go through memory-based paper of mains exam, which was conducted on 2nd of September, first shift. The paper is not complete because the paper had 25 questions. Students were not able to recall so far all the questions. Number of questions available as of now are about 17 questions in physics. So let's go through the questions in physics which have come today. And you notice overall the paper was quite easy. It was definitely on the easier side, and which had been the trend in the recent past. Even this last session also, last cycle of mains also, paper was fairly easy. So let's look at first question. First question is based on magnetic properties of matter, and this also pretty straightforward question. And this is a theoretical question, and most of you would have done this question. So this is, I'll put in a very easy category. Okay. This we know the property, coercivity and retentivity. This was okay, moderate question, and this is based on orbital motion of a planet. Okay, so circular motion. So what is given here? In this particular case, there's a hypothetical galaxy, and mass is distributed all over, and density varies as the distance from the center. So this galaxy has some kind of hypothetical center here, O, and the mass is distributed all around it in the galaxy. And what we notice, as the distance keeps increasing, the density of how the mass is distributed in the space also keeps decreasing. So in this particular space, so there's a planet which is undergoing orbital motion. Let's say this planet has mass m. It is orbiting in a radius of r naught here. So this is kind of orbital path it has. Okay, and we know which principle, and we need to find the time period. So in all cases, it is based on gravitational force of attraction acts as the centripetal force. So we solve such question by equating gravitational force of attraction to centripetal force. But here the difficulty is when we apply which is the mass which is exerting gravitational force of attraction on the planet here. We know whenever mass is spherically symmetric, whenever mass has spherical symmetry. In this particular case, it has spherical symmetry. If mass is distribution is spherically symmetric, only the part of the mass which lies within a imaginary sphere of radius r naught will exert force on this mass. Any mass which is outside this imaginary shell will not exert any force. And what would the force be? So this is simply based on gravitational force of attraction. This will be equal to g times. What is the mass we'll take here? Mass contained within a radius r naught. That's the mass of a galaxy we need to take into mass of satellite, and square of the distance from the hypothetical the center here, and this will be my m into r naught omega square. So only challenge here is calculation. What is the mass contained within radius r naught? So that's what only thing we need to find. What is mass contained within radius r naught? And here, since the density is not uniform, we can't calculate mass simply multiplying density by volume. So we have to divide this overall volume into elemental volume. So what kind of elemental volume I should select for which the density, here the density is varying with distance r. So quite obvious, we need to consider this entire spherical mass as several concentric spherical shell. So in this case, we'll calculate the mass of a random spherical shell of radius r and thickness dr, or inner radius r, outer radius dr. If we calculate mass and we add up all the masses from 0 to r naught, we'll get the total mass here. So what will the mass be equal to? Mass will be equal to this. Now the density is uniform in this, since the distance is constant, and that will be equal to rho r, which will be k by r, and volume will be equal to surface area 4 pi r square into thickness. That is a dm, which comes equal to 4 pi k into r dr. So what is the total mass here? Total mass will integrate, we'll add it up from 0 to r naught into dm. And it's a very simple integration. It will become r naught square by 2. So it will become 2 pi k r naught square. That's the mass contained. And let's just simply substitute here and very easily get your answer. It's 2 pi k r naught square into m divided by r naught square is equal to m r naught omega square. Of course, this gets cancelled, this gets cancelled. So what are we left with? Omega square is equal to 2 pi k into g divided by r naught. Hence, what will the time period? Time period will be equal to 2 pi by omega. And we put these values, that will be equal to 2 pi r naught and 2 pi kg. And if we just take it inside this square root, it will come equal to 2 pi r naught by kg. So which is the answer. So this was medium difficulty. This is not so difficult. Most of the students must have done something similar, some similar question. If you recall those, you could easily solve. Next question. This question also I would put as an easy category, because this is a very common question on rotational equilibrium, which most students must have done. So this is a rod, uniform mass, and there's some mass also suspended here. What we need to do here, whenever it is suspended, it is in the state of rotational equilibrium. So there's a tension acting in this string, and there's a tension acting in this string. And in case of rotational equilibrium, we'll have three equations: summation of forces in y direction 0, x direction 0, and torque about any point is 0. Since we have to find TA, its easiest method is, of course, to take the torque about B as 0. In that case, the TB will not come into equation. So you can easily solve this question by taking the summation of all torques about point B equal to 0. So here three forces, this will not have any torque. There will be torque due to weight of the rod, due to this weight suspended here, and tension in the string. And this torque and this torque are equal and opposite. That's what it has to be. So we simply will equate the torques. So due to tension, it will be TA into perpendicular distance. Since all the forces are vertical, perpendicular distance will be around the horizontal length, which is equal to 100. We can write in centimeters also. Both sides same unit will cancel out. And it will be equal to mg into this distance 50. And other torque also due to 3 mg here, and 3 mg at a distance of 25. So from here very easily you can solve. We can get the value of TA, which comes equal to 5 by 4 mg, which gives you value of K as 5 by 4. So I can all agree this was a fairly easy question. This was the question. Okay, what we need to calculate here? What is the here? Okay, a coil of radius r is rotated in a magnetic field, and we need to calculate what is the voltage developed. So quite easy to spot. This one is based on concept of EMI, Faraday's law. So it is based on what is EMF developed. EMF developed is equal to rate of change of flux. And in this case, okay, so d by dt of what is flux equal to B into A of cos of angle between these two vectors. See what is happening in this case, the reason why flux is changing is because angle between the coil and the magnetic field is changing. Angle between area vector and B vector is changing. Okay, so as the angular velocity is omega, so angle between them, if we don't know what initial angle is not given, so we'll assume the initial angle between area vector and B vector was some phi. So at time t, what will the angle? At time t, angle becomes omega t plus phi. So this can be written as BA into d by dt of cos of omega t plus phi. We are interested in only magnitude. So what will be magnitude of EMF which will get developed? We differentiate very simple. It will be equal to BA omega sine of omega t plus phi. We are just ignoring the sign negative term. And since we are interested in maximum value, the value will maximum, and this term is equal to 1. So maximum value, maximum value of EMF will come equal to BA omega. Is omega given here? It takes 0.2 second for half a rotation. So it means t is equal to 0.4 second. It will take 0.4 second for full rotation. So omega is equal to 2 pi by t. If I substitute, I get equal to 5 pi. So I'll substitute these values. What is B given here? B is given in 5 into 10 to the power minus 5. And area also is given in terms of radius. So 1 by 10 whole square into omega with 5 pi. Only thing what you notice here, there are two pi terms coming here. And since the answers are not very close to each other, we can approximate pi square as equivalent to 10. If we just say approximation, we can easily get this answer without too much of calculation. So how would you put this one also? This also is a easy to moderate, easy question, not even moderate. So this kind of question also most students must have come across. EMI. Next question. This is something, okay, moment you see the figure, many of you can immediately spot what this question is about. This question is fairly simple one. Either we remember the formula, even if something we need to know. Basically, one way, I think some of you recall the formula, it is equal to R square, omega square by 2G. And those who do not recall, at least minimum what you should remember, in case of horizontal acceleration, the slope. What is slope equal to? So since it is circular motion here, either I think dy by dx, I can write the vertical distances. Okay, so I can write it rather than dy by dx, I can write as dh by dr. Okay, the same thing, dy by dx is equal to, actually we write as minus ax by g. In this case, ax is equal to minus r omega square. Acceleration in the horizontal direction, not constant, is varying as a distance from the center. So it becomes equal to r omega square by g. And from here also we can easily calculate. And we substitute this term, we get an answer. So this also was a fairly okay, easy question. This also comes into easy question. So anybody who's practiced basic question must have done this question, and no complexity involved. It's a direct question. This is based on dimensional formula, based on not MLT as fundamental physical quantity. Which are the quantities taken as fundamental quantity? Force, velocity, and area. Okay. So there's all of you know how to arrive at a dimensional formula. But in this case, it is even easier. Actually, you don't have to take the longer route here. I need to express Young's modulus in terms of force, velocity, and area. But I already know what is Young's modulus. Young's modulus is nothing but force by area. So I don't, since I know this relationship already, no analysis necessary. So, so dimensional formula for Young's modulus will be equal to dimensions of F divided by A. If these two are taken as fundamental physical quantity, is dimensional formula will be equal to F to the power 1 and A to power minus 1. So it was very direct question. I think this is something, this also is very easy question. Next question is a little tricky one. What is the order of resistivity? And this is something I think we don't pay attention what the resistivity is, but we'll have some understanding. See, this is something this question we'll not remember, and normally people don't pay attention, but we can use certain common sense based on our understanding. We all know that metals have good conductors, low resistivity, and in home wiring we use copper wire. Reason we use copper wire, copper wire has low resistivity. So this one option given, we can, yes, the copper wire will have low resistivity. Aluminum also is good conductor, that also low resistivity. And then water also we know is a really good conductor. And based on the option given, based on these 2-3 things, we could have guessed. Otherwise, this was more of a, not even memory based. We'll not call this memory based because normally nobody tries to memorize. This would I put is one of those questions which are a little bit tricky. And if you have some common sense and little lucky, you can easily guess it. Okay, this question is relative velocity and fairly simple application of relative velocity. There are two trains moving. Let's say which are the two trains. Let's say take, and they're moving in the opposite direction. So any direction we take doesn't matter. So let's say this train A is moving with the speed of 36 meter per second. What is 36 equal to? That is equal to 10 meter per second. So this is moving with the velocity of 10 meter per second. And there's another train, it could be placed here or here, doesn't matter. So they're moving. There's another train B, which is moving in the opposite direction. And B is moving with a velocity of 20 meters per second. So we have converted this kilometers per hour into meter per second. The final options were in meter per second. And there's a man walking in the train A. Yeah, so you can, I think all of you can relate to this particular case. When you're walking inside a moving train, your speed is not same as train speed. Your speed difference now is something else. Which direction is walking? He's walking as his speed is walking the speed of 0.5 meter per second. Okay, this is walking the speed of 0.5 meter per second. Which direction? Opposite to direction of train. So he's walking. So since all thing is one dimension, and if I take this direction as positive, this velocity is plus 10. This velocity is minus 20, and velocity of man, what is given here? Velocity of man with reference to train A is equal to, is walking opposite, minus 0.5, which is equal to velocity of man minus velocity of train A. Okay, and what is train A? This is 10. So what does this tell you? It tells you velocity of man in the ground frame of reference. In ground frame is 9.5 meter per second. And we know the ground velocity of B. What we need to find? Velocity of man as seen by train B. So we need to find VMB, which is equal to VM minus VB. And they're fairly simple one, all in one dimension. So this one is plus 9.5 and minus of minus 20. So this becomes equal to 29.5. So as seen by a person in train B, this man will be appear to be moving towards right with the speed of 29 meter per second. So this also was I would say a fairly easy question. So you find most of the questions were pretty direct. Look at this. This also is extremely direct question. Object is this in case of concave mirror. Object is placed beyond center. So whenever it is placed beyond center, what will happen? The image will form between something like this. We can easily draw a figure and something like this. This is how the image will form. Image will form between, this is inverted image, real image, and diminished. We can easily identify. And this is something, this is a very easy question. Again, we come across another question which also may call for, if not very easy, at least easy category. Thermodynamics, what we need to find the total energy. And total energy, we know what is total energy equal to. Total energy equal to F by 2 nRT. If there are multiple gases involved, we take the summation of this. So let's take in first case, it is this is the diatomic. In diatomic, degree of freedom is 5. So this is 5 by 2 number of moles into RT. And then we'll add 5 moles of argon. Argon is monatomic. So F degree of freedom is 3 by 2. And 5 moles of that, 5 into RT. So this was very easy question, very easy to solve. Okay. 15 RT is the answer. And no simple, even the calculation also extremely simple. Okay, this is something, okay, this is medium to, okay, this is medium, a moderately difficult question. This is based on collision. So collision also, let's mark. This is something, this is, I think, just go through the question. So some of you feel necessary, you can pause the video, go through, understand the question, and then proceed further. This is the rest, collision takes place. This is before collision, this is after collision. So it has certain velocity, some velocity. Its velocity, direction, and angles are not given. So let's take, it has velocity, this is equal, this side is Vx, and this direction, it has Vy, magnitude. From conservation of momentum, we can easily find out mu has to be equal to 3m into Vx, or Vx will be equal to u by 3. And here, initially, momentum in y direction, basically we are just taking xy, normal convention. Since the momentum in y direction was initially 0. So these two also have to be equal and opposite momentum. So this is mv and this is v by m, mass is 3m. So this has to be equal to v by 3. Okay, so this and is elastic collision. What we need to find? We need to find value of v. So, so since collision is perfectly elastic, conservation of energy. If we conserve energy here, we can get an equation. Only one unknown v. So let's write what is the energy of conservation. If we conserve energy, 1 by 2 mu square is equal to 1 by 2 m into v square plus 1 by 2 into mass is 3m and u by 3 whole square plus v by 3 whole square. It's pretty simple solution, and this gets cancelled, m gets cancelled. What are we left with? U square is equal to v square. This 2 also gets cancelled. It becomes equal to u square by 3 plus v square by 3. So you get what? 2u square by 3 is equal to 4v square by 3, or easily get u is equal to root 2v, or v is equal to u by root 2. So this also was a okay moderate question, and doesn't take much time to solve as well. Okay, this question, moment you see inclined plane smooth and rough and all these kind of questions, most of you will be familiar with. And this also fairly easy, basically laws of motion and work power energy chapter. Let's understand here. So what it starts from rest and set rest. So basically this question is based on delta kinetic energy is 0. If change in kinetic energy is 0, the work done by all forces also have to be equal to 0. Which are the forces doing work? Work done by gravity plus work done by friction has to be equal to 0. Or in terms of magnitude, yes, of course, as you move from here to here, gravity will do positive work, friction will do negative work. So we can equate those magnitude. What is as it moves from? So basically, I'm applying from where to where? Whole thing I'm applying from B to A. Initial point is my B point, and final point is A point. Okay. So in this case, as it moves from here, gravity, what is the work done? We can easily know here. Let's take the total length of the inclined plane as L here. And what is given? BC is okay, BC is twice of this, so this will be equal to 2L by 3, and this length will be equal to L by 3. Okay, and the height will become equal to L sine theta. What is work done by gravity? Work done by gravity is very easy to calculate. We can take the component of displacement along the direction of mg, which will become mgl sine theta. That's work done by gravity. And what is work done by friction? From B to C, there's no friction, no work done. From here, only friction force will act. And what will the friction force be equal to? Work done by friction. So it's a negative, but we are just calculating magnitude. Negative part we are already taken care of here. So, or we can write as negative also. So work done by friction force will be equal to friction force into displacement. It will act along the length. So displacement along the since force is along the displacement into L by 3. Angle between friction force will act upwards, displacement downward. That's why the negative sign. It is equal to mu mg cos theta into displacement. Displacement is L by 3. Let's put the value and we'll substitute it here. We get this equation mgl sine theta. And let's put this value of mu. What is the value of mu given here? K tan theta. L by 3. Okay. So do we get value of k here? We have to find the value of k, which is pretty easy. K is equal to 3. But this also was an easy question. Okay, one more question on rotation, but this also is a fairly, you notice, is not too difficult a question. At max, we can put as a moderate level question. This question applied perpendicular. This is how the force is applied. This is, imagine there's a rod here. Again, you're applying the force perpendicular to, and this kind of step is lying here. Just imagine a minimum force applied where center of the ball. Ball is lying here. What force you need to apply to just move the ball up. Okay. Lift the ball. So lift the ball, basically what will happen? It will lose contact here. So first thing what you need to understand, no contact force will act. It will get lifted. That's first point. And will it be in a state of rotational equilibrium? No, actually this force is trying to rotate about point P. Point P will be the point of rotation or axis of rotation will pass through point P perpendicular to the plane. And this torque is trying to rotate. And what is the other force acting? Mg is acting. And there's some force acting here also. But this force will not have any torque about it. Okay, so there's force acting at the point of contact. There's no contact force here because the ball gets lifted up, and there's mg acting here. Okay, so what is this based on? So basically the torque which is trying to rotate has to exceed the torque which is resisting, or net torque in this direction has to be positive. What is the torque acting here? So these two forces, if I am taking torque about point P, because that's the axis of rotation. Torque about point P, which direction if you take in this direction has to be greater than 0. Okay, that's how it will rotate. So in talk about, if we take in a clockwise sense, what is the torque about point P? If we take in the clockwise sense as positive, F into perpendicular distance from P. Since it is perpendicular here and angle is 90, the torque of F is equal to F into R. And these two forces will have no torque, and there's no contact here. Other torque is only mg. So mg also, what is the perpendicular distance? Mg is vertical, so I have to take this horizontal distance. If this is A, this side of the triangle becomes equal to R minus A, and this side is R. So what is the perpendicular distance we have to take here? What is the distance at which it's acting? This is the perpendicular distance. So what is this distance comes to? Fr minus mg into this distance here. The distance here is how much? R square minus R minus A whole square. This has to be equal to greater than 0. Okay, so or what has F equal to, we can easily find this expression. We can easily simplify. So this becomes, okay, 2r minus r square. That's the term here. So this is also a fairly simple question. This is okay. Okay, this photoelectricity. That's a stopping potential kind of question. And so this also is a fairly common question, an easy question. Most of the people should have done this question. So we are ready. So what we say here, what is the energy of okay. So what it is based on? Energy of photon is equal to uh, stopping work function plus energy of fastest photoelectron emitted, which we measure in terms of stopping potential. So we write what is the equation. So basically, if this is the energy of incident photon, which is of wavelength lambda, is equal to work function plus EV. If we write in this one in joules. Okay, this question. So there are two cases given. Let's say initial case. First case, what is given here? Emit photon is V, stopping potential is V, wavelength is lambda. Okay, so this is the equation. This is my first case here. This value given. And what is the second case here? We change some of the parameters here. We are not changing the material, so phi will not change here. The stopping potential becomes equal to V by 4 if wavelength is 3 lambda. Wavelength of light incident. So it becomes SC by 3 lambda. So energy of incident photon becomes 1/3. Of course, the stopping potential also becomes smaller. It becomes equal to E into V by 4. That's the second equation. And what we need to find? We need to find the value of threshold wavelength. So I could have written this as to find threshold wavelength. Even stopping this work function can be written in terms of the threshold wavelength, SC by lambda naught plus EV. And this also can be written as SC by lambda naught plus EV by 4. Okay, so these are two equations given. So all you need to do is pretty simple. This will be multiplied by 1 by 4. So this equation will multiply 1 by 4 so that you can eliminate V term here. So if we multiply 1 by 4, the equation becomes SC by 4 lambda is equal to 5 by 4 plus EV by 4. Okay, and sorry, this equation SC by 4 lambda naught plus EV by 4. That's the second equation. So when we take the difference of the two, we can easily solve for lambda naught. So this also was a fairly easy question. Okay, this also is very, very easy question. This is based on waves and sound chapter. And this also comes into very easy question. So what is fundamental frequency of a string fixed at both ends? Fundamental frequency is V by 2L. Since the tension is given, you can write it 1 by 2L root of T by mu. So in this case, since two identical strings, mu also is same, L also is same. So this is based on Fx by Fy will be equal to root of Tx by Ty. Tension in the string X and tension in the string Y. And Fx by Fy is given 450 by 300, which is equal to 3 by 2. Hence, Tx by Ty will be equal to, pretty simple, actually very, very easy question. This is 9 by 4. So this also comes under very easy category. Okay, this also on capacitors. This also I could put in a very easy category. We know one capacitor. See, we know this kind of thing. See, suppose we have capacitor. One capacitor is C1, is charged to potential V. So it has charge C1V. If we connect it to another capacitor, C2, which has no charge initially, we connect it like this, what will happen? This system is equivalent to a capacitor. Since these two are connected in parallel, we can treat them equivalent to a capacitor having capacitance of C1 plus C2 because they are connected in parallel. And what is the charge? C1V. So in this case, what is the loss of energy? So this is what you have to calculate. What is the heat loss? What is loss of energy? Loss means initial energy is more in Ui minus Ui. What is initial energy is only in the first capacitor. It is equal to 1 by 2 C1 V square. And minus what is the final energy? 1 by 2. Sorry, in this case, I'll write in Q square by 2C formula because that is known. Charge is known. So it is C1V square by 2C. Q square by 2C, C1 plus C2. So that's the value. Now we can easily substitute those terms. What are the values here given? We can easily simplify. So we can easily solve. So this question also was a fairly easy question. This also is a common question. Okay, sometimes it is given in case of a spherical ball, sometimes given in parabolic shape. In this case, whenever it rotates, with respect to it, in this case, it does not slip. It means in the frame of, with respect to the parabola, it is in the state of rest. And since parabola is having angular velocity omega, so if you have to look from like an equilibrium, we need to apply a pseudo force. Pseudo force will be equal to, since coordinate is AB, pseudo force is equal to R omega square, and R is equal to X coordinate here. The pseudo force is equal to A omega square. And other force, real force, which is acting is mg. So what has to happen? There's a resultant force here. The resultant force must not have any component along the wire, or this force must be perpendicular, or it must, if we draw a tangent at this point, resultant force must make a 90° with the tangent. Then only it will be in the state of equilibrium, no tangential component. So let's say the tangent makes an angle theta from the vertical. This force must make a big angle theta from the, sorry, this makes, if tangent makes angle theta from the horizontal, this force must make angle theta from the vertical. Then only mutually perpendicular. And tangent angle made from the horizontal is nothing but dy by dx. So what has to happen? Dy by dx has to be equal to this angle the resultant force makes with the vertical. So what is the resultant? This is mg, and other force is, sorry, ma omega square. And the other force is ma omega square. So can we find tan theta here? This is equal to tan theta. And what is the tan theta be equal to? The tan theta horizontal component divided by the vertical component. It will be equal to ma omega square divided by mg. And what is dy by dx here? Dy by dx is equal to 8cx. And what is the x component here? This is equal to 8cx. And x is equal to a. So it is equal to 8ca. Okay. Just a second. I think I forgot to connect the battery. Okay. So 8ca, and that's the equation we get here. So can we find omega value? Fairly simple to find omega value. Okay, so what is this one? So this answer, it comes equal to omega square is equal to 8 gc, which is equal to 2 root 2 gc. So that's all. I think that's the question what we had. I think all of you will agree that it was a fairly easy paper, and